So today's topic is energy balance. Those who have the textbook, it's on page number 126. If you have the new textbook, new edition, page numbers may slightly vary. Okay. So page number 126, chapter 7, energy balance. New textbook, it is page number 130. So if anyone is joining late, please help them out with the page numbers. So 60 to 70% of energy used by your human body is released as heat. You touch yourself, you touch your palms, okay? You find it warm, okay? Generally, it is warm until and unless it is a winter season or you're out or you're undergoing some stress or anxiety, okay? In such cases, the hands become cold, clumsy, or you may have thyroid issues, okay? In that also, the hands become cold, clumsy in hyperthyroidism and all. Okay, apart from that, for generally for a healthy person, for the healthy population, majority of them, okay, your body generates heat. Okay, so 60 to 70% of energy, the whatever food you're eating, okay, it is released as heat. The remaining is used for muscular activity, cellular process, etc. Okay, so kilocalorie, we always represent when you make a menu plan or a diet plan. Okay, we have a borderline that your diet should be within this category. Your diet should be within this particular calorie. Okay, that is counted in kilocalorie. So what is this kilocalorie? What is this new unit of measurement? What is the definition of this unit of measurement? Okay, so energy is a in biological systems is always measured in kilocalories. Okay, so by definition, what do you mean by kilocalorie? By definition, 1 kilocalorie is the amount of heat energy needed to raise 1 kg of water 1 degree Celsius at 15 degrees Celsius, which means, just imagine, when you read this definition, it is quite confusing, but just imagine, what is 1 kilocalorie? I give you 1 kg of water, okay, which may be at 14 degrees Celsius. The temperature of the water is 14 degrees Celsius. Imagine, I gave you 1 kg water. 1 kg water is approximately 1 liter almost. Okay. So I gave you 1 kg of water and I ask you to increase the temperature of this 1 kg of water just by 1 degree Celsius. Not 2, not 3, not 10. I just want you to increase the temperature of this 1 kg of water just by 1 degree Celsius. Okay. So when I gave you 1 kg of water, it is 14 degrees Celsius. I just want you to make it to 15 degrees Celsius. 1 degree Celsius increase. That's it. Okay. So you will definitely require heat. You need heat to increase the temperature of anything, even if it is water. Okay. To increase the temperature of water by 1 degree Celsius, you will require heat. Okay. So the amount of heat energy that you will use just to make this change from 14 degrees Celsius to 15 degrees Celsius. Okay, that 1 degree Celsius increase you want to bring. So the amount of heat energy you will use, that is 1 kilocalorie. Okay, the amount of heat energy used to change the temperature of the 1 kg water just by 1 degree Celsius. That is 1 kilocalorie. Just 1 kilocalorie is the amount of heat energy used to shift 1 degree Celsius. Is it clear to all? Am I audible? Is it clear to all? Is my screen visible to all? So the definition of 1 kilocalorie, I guess everyone knows it. If you want an animated video of it, WhatsApp me. I will send you an animated video of 1 kilocalorie. Okay. I will forward you the animated video of 1 kilocalorie so you will understand it better. The definition of 1 kilocalorie. Okay. So how do you estimate the heat produced? There should be some appliance, right? Something, some instrument should be there, some equipment should be there, which will help you to estimate how much heat is released, okay? Or how much calorie is being produced, or how much calorie is being burnt. Something human beings should have developed so far, okay? So this equipment is calorimetry. What is calorimetry? Calorimetry, measuring calories. The word meaning of calorimetry is to measure calories, the calories being burnt. Okay, the heat required to burn calorie, that is also, when you estimate that also is calorimetry. Okay, so you have two types of calorimetry, direct and indirect. Okay, in detail, the detail of how calorimetry works, okay, the biochemistry of it, the mechanics of it, that you don't have to study as a nutritionist, and as a dietitian you don't require it. Okay, just understand what calorimetry is, what is the difference between direct and indirect calorimetry, just understand that. Okay, you don't require to you don't have to study anything more than that, even in the textbook. Okay, you just have to understand what is direct calorimetry, indirect calorimetry, and examples of it. That's it. Okay, apart from that, whatever paragraphs they have given, you don't have to go through that for examination. From exam point of view, this is not important. Okay, but what is calorimetry? You should know. Measurement of calories, finding out how many calories are burnt. Okay, so uh, uh, see, if I give you a task, one katori of curd, okay, one katori of curd, how much calorie it will give? If you Google search it, will you get the answer? Or any food, okay? If I give you the task, okay, 1 gram of it, or one portion size of it, one bowl of so and so food items, okay? What is the calorie? If you Google search it, will you get the answer? So how did these people come up with these exact calories? It is because of calorimetry. Okay, so when you eat food, whatever food stuff you eat, it goes into your body. Along with that, you're inhaling, you're breathing as well. Okay, you are alive, you're breathing. Along with the food and oxygen, it is required to produce heat in your body, to release carbon dioxide, to make metabolic water. The H2O you see here is metabolic water. Metabolic water you don't drink, your body produces by itself. Okay, as a byproduct of many reactions, many metabolism, as a byproduct of that, water is produced in your body as well. That is called metabolic water. Okay, so when you eat food, you breathe in oxygen, your body is able to produce heat, your body is able to produce carbon dioxide, your body is able to produce metabolic water. So far, is it clear? This equation, is it clear? So now whatever is produced, based on that, you will find out how much calories are being burnt. Okay, so that if you take this heat factor, the amount of heat that a food is generating along with oxygen, okay, the amount of heat a food can generate along with oxygen, when you only look at this heat, you are performing direct calorimetry. Okay, when you only look at this heat generated by a food, okay, by a food, any food item, along with oxygen, the heat what is generated, okay, when you just look at this byproduct, you are doing direct calorimetry. Direct calorimetry is done in laboratories. You burn food items, okay, any food items, vegetables, fruits, or whatever, it is done in a laboratory. Okay, a specific bomb calorimeter is available. Okay, in direct calorimetry, bomb calorimeter or Alwater Rosa respiration calorimeter. So these calorimeters are used only to catch heat, to see how much heat is produced. With that, we will understand how much calories are being burnt. Okay, so that is direct calorimetry. What about indirect calorimetry? Okay, here a person, for example, a person will be put on treadmill, or a person will be put on some elliptical exercise machine. Okay, they will be covered on their mouth and nose will be covered with a mask, a special mask, and this mask will test how much oxygen this person is breathing in and how much carbon dioxide this person is releasing. Okay, how much oxygen and how much carbon dioxide this person is releasing, breathing in. Temperature, they will have vital signs to check the temperature and all. Okay, so just by checking how much oxygen this person is inhaling and how much carbon dioxide is being released, based on these two components, when you find out how much calories are being burnt, that is called indirect calorimetry. Okay, in indirect calorimetry, we are not looking at the heat produced, or we are not looking at the sweat that is produced. Okay, sweat is also metabolic water, it's a byproduct of your metabolism. Okay, so in indirect calorimetry, it is just the combination of oxygen and carbon dioxide which is inhaled and exhaled. When you calculate that, how much liters of oxygen were inhaled, how much liters of carbon dioxide was exhaled, based on that they will do the calculation to find out how much calories were burnt. In direct calorimetry, no oxygen, no carbon dioxide, directly they will test the heat produced. Okay, is it clear the basic difference between indirect calorimetry and direct calorimetry? So this is a bomb calorimetry. Okay, this is a bomb calorimeter. It comes under direct calorimetry. Okay, so you put some food particles, food stuff is used here. Okay, a specific heat is generated to burn it. Okay, the temperature of the heat is seen, how much heat it is required to break down this food and burn it. Okay, that gives the calories. So it is done in a laboratory. Okay, outside of human body. Okay, so this is a direct calorimetry, a bomb calorimeter. It is used to burn food and see how much calories are being produced. Okay, and this is the indirect calorimeter. You can see here a person is on some elliptical machine. Okay, and then a specific mask is put on his mouth. Okay, because that will have a control. It is connected to other devices that will monitor how much oxygen this person is taking in and how much carbon dioxide they are releasing. Along with that, the person's body temperature will also be checked. Okay, so this is indirect calorimetry, where a person's oxygen inhale how many liters of oxygen were inhaled, how many liters of carbon dioxide were exhaled. Based on that, we will judge how much calories were burnt. Okay, so from indirect and direct calorimetry topic, that's what you have to study. Okay, don't go any further than this. If you understand the basic difference between these two, that's more than enough. Okay, coming to the physiological fuel value, page 129. Calculations and all you don't have to study at all. Okay, questions won't come from that. That is too chemistry based questions and all, that is not involved, that is not required. Coming to the physiological fuel value. Okay, so as we know, we have discussed it many times, proteins, carbohydrates and fats, these are the macronutrients. Okay, you don't have to purchase these machines at all. Okay, this is only for these machines are specifically used in institutions where food based researches are done, researches on how a sports person performs, how athletes perform. Okay, only these kind of institutes require these equipments. Hospitals, okay, where athletes or sports persons are being tested on their output, on their resistance, where they're trained well based on their diet and all. Okay, these kind of institutions will require the equipments like this, and also food research institutions will require equipments like this, not any individual practitioners. Okay, so physiological value of food, macronutrients, macros what we call is proteins, carbohydrates and fats. Okay, 1 gram of protein, 1 gram of carbohydrate, 1 gram of fat, how much energy they are helping you to, they are giving you. Okay, so 1 gram of protein gives you approximately 4 kilocalories of energy. Carbohydrates will also give you 4 kilocalories. Fat will give you 9 kilocalories of energy. And if it is alcohol, alcohol gives you around 7 kilocalories of energy per gram. Okay. So these are the, but we don't consider alcohol as a macronutrient. Alcohol does not have any nutrient value. It only has energy value. Okay. So these are the physiological fuel value. Okay. Physiological fuel value is slightly different from the laboratory fuel values, because when you eat proteins, carbohydrates, and fats, the entirety of it is not accounted by your body. Okay. There are some exceptions, because some part of the food is lost in digestion. Okay. Some undigested food stays in your intestine, and it will be fermented by the intestinal bacteria. Gut microbiome will use it. Okay. It is not for the body's fuel purpose, it will be for the gut microbiome, and some part of it will just leave your body through the excreta. Okay. So accounting the physiological loss of food as well, we have come up with these fuel value. Okay. Even if you give, for example, 1 gram of protein should give you around 4 kilocalories. Okay. But if you have 10 gram of protein, it should give you, by this formula, it should give you around 40 kilocalories of energy. But that is not exactly how the body takes in. Okay. It could be 35 kilocalories of energy or 38 kilocalories of energy. Some part of it is lost in digestion, especially if you're having a lot of fiber rich food. Okay. Fiber won't allow your intestine to get into these macronutrients easily. Okay. So that will get trapped, these macronutrients will get trapped in the matrix of your fiber, and it will leave your body as it is. Okay. So keeping those things also into account, physiological fuel value, we keep it in this range. Okay. The gross for fuel value is given in the textbook, table 7.2. Table 7.2. If it is about protein, 1 gram of protein is supposed to give you 5.65 kilocalories. But in human body, protein will give you only 4 kilocalories. Outside of human body, if you're burning a protein based food, 1 gram should give you 5.65 kilocalories. Okay. Protein is difficult to break down. Metabolically, protein is very difficult to break down and to be utilized in the body. Okay. Your body has to burn energy to get energy from protein. That is the truth. Your body has to burn calories to get calories from protein. Okay. So that's the reason why for weight loss and all, we focus on protein rich food, because when you're eating protein rich food, it is not just giving nutrition to your body, it is making your body work harder just to metabolize, just to metabolize and burn the body fat. Okay. It is making your body automatically into a fat, into a calorie burning machine, because proteins are difficult to break down. Okay. Your body loses energy just to metabolize and digest protein. Okay. Take fiber rich food with any fatty food. Okay. With any fatty food or a carbohydrate rich food. Okay. Keep proteins a little bit separate from fiber, because you don't want to lose protein. Whatever you take in with fiber, fiber will reduce its absorption. So if you're taking some fatty food, it is best to combine it with fiber. Okay. So, and gross value of carbohydrates, 4.15 outside the human body, 4.15 kilocalories per gram. Okay. Fat, it is 9.45, and in physiological value is just 9, but gross value it is 9.45. Okay. Is it clear to all? Then components of energy expenditure, how your body utilizes the energy from food that you give. Okay. So majority, a major chunk of your energy is lost in just metabolism, resting BMR. Okay. Metabolism, metabolic rate, rest or better resting metabolism. You're not doing anything. You may be just lying down, sleeping, resting. Okay. Scrolling on your mobile, gaming. Okay. You're not doing anything that is tedious. Okay, just resting, still your body is functioning, you're breathing, your heart is pumping blood. Okay, involuntary muscular activities are taking place inside your body. Okay, for which also energy is required. Okay, so that is your resting metabolism. Even if you don't do anything, you can still lose weight with a proper diet. Okay, put yourself in a calorie deficit. Okay, eat the food, eat the amount of how do you lose weight without doing any exercise? Only through calorie deficit diet. Okay, only through calorie deficit you can do it. Your whatever you see your resting metabolism, that is also in calories. Okay, eat less than that and see how you will lose weight without doing any exercise. That is the basic truth. But you may also tend to lose your muscle mass in that. Okay, strength gaining will not happen. You will just lose weight, but there is no gain in strength. Okay, next big chunk is the physical activity. You wake up. Okay, you move around the home, you do your daily whatever is your daily rituals. Okay, the way how you have a schedule. Okay, even if it is some household chores and all, going to office, traveling to work. Okay, cycling or walking, brisk walking, whatever is your physical activity. Okay, 32% of your energy goes there. And next is 8% is thermic effect of food. For digestion, some specific food, some specific food creates more heat in your body. Some specific food need additional calories, okay, from your body just for digestion. This is thermic effect. Okay, for example, protein. Okay, or just imagine if you have salad, a bowl of salad and a bowl of biryani. Okay, if you have a bowl of salad, if you have a bowl of biryani, which do you think your body has to work hard to digest? Which do you think has more thermic effect? It will be biryani. Okay, because salad your body will easily break down. It is just fiber. Okay, your body will try to break down. It is fiber, it's a fiber matrix mesh will be created, and your intestine will give up. Your intestine will give up. We are not wasting any time on this. Okay, let it pass by. So after having a bowl of salad, you will at that moment you will feel full, but within 2 hours you will feel hungry. Okay, but after having a bowl of biryani, it is not the same. Okay, you will feel full at that particular time, and even after 2 hours you are still full, because your body is utilizing its energy to break down the protein, break down the fat. Okay, to digest the biryani, the body is going into a state of calorie burning machine to digest that biryani. Okay, so thermic effect of biryani is more as compared to salad. Now coming to basal metabolic rate. Okay, BMR. So what is BMR? This is the amount of energy required to carry out involuntary work, which is not under your control. You are not controlling your breath. You are not controlling your heartbeats. You are not controlling your digestion. Peristalsis movement in your body, how food moves inside your body. You don't have control over that. Okay, the way how your brain works, how your thoughts come when you do calculations, when you study. Okay, how your brain should utilize the energy. Okay, you are not in control of that. So these, the way how kidneys are filtering out blood. Okay, so these things are completely involuntary. Okay, so you don't have any much control over it. Because these are involuntary activities. So the energy utilized to do these activities for survival, okay, so that energy comes under basal metabolic rate. Okay, functions of brain, heart, liver, kidneys, lungs. Okay, secretion of hormones, production and secretion of hormones in your glands, peristaltic movement of the gastrointestinal tract. Okay, oxidation happening in every tissues, maintenance of muscle, okay, maintenance of your body temperature. These things are not in your control, so energy is required for all this, okay, for your basic survival. Okay, so that comes under BMR. Men and women have a different BMR. The way how you calculate BMR rate for men and women is different. Why? Hormones influence your basal metabolic rate. Hormones influence your basal metabolic rate. The amount of lean muscle that you have influences your basal metabolic rate. Okay, so definitely men and women are different on these two biological terms. Okay, men have men have more lean muscle, men have more skeletal muscle. Okay, so to maintain this skeletal muscle, more energy is lost. Okay, men have testosterone and androgen. Okay, that is energy giving hormones. Okay, women do not have that much testosterone and androgen as compared to men. Okay, so that slows down their BMR. So that is the reason why men and women have different formulas for BMR, because physiologically, biologically, they are different. How their body is built, how their body functions at hormonal level is different. Okay, is it clear to all? So yeah, this is the formula for men. So here in this formula, they have used weight in pounds and in height is in inches. Okay. There are other formulas. This is Saint George and Mifflin formula. If you convert it into the weight into kilograms and height into centimeters, obviously the other matrices will also change. Okay, here they have taken weight in pounds and height in inches. That's the reason why you see the formula which is slightly different from what is given in your textbook. Okay, in your textbook there is a topic called determination of basal metabolic rate by calculations. Those who have the old textbook, it's page number 137. Those who have the new textbook, please put the page number in the chat box. The topic name is determination of basal metabolic rate by calculation. In your textbook, it is page number 141. So there you will find some formulas. These formulas can also be used to determine your metabolic rate. Okay, apart from Saint George and Mifflin. And in every formula, you will see there is a difference in male and female. For female, they have a different formula. For males, they have a slightly different formula. Okay. But usually in majority of our calculations, we are using the Saint George and Mifflin formula, which we will come to later. I'll show you the Mifflin equation. These are the options that you have. Determination of basal metabolic rate by calculation. These are the other options that you have. You can come to the page number of resting energy expenditure, page 144. Those who have the textbook, the topic name is resting energy expenditure. New textbook, you can put the page number in the chat box. There you will find the Saint George and Mifflin formula, in which weight is in kg, height is in centimeter. Okay, that is what we usually use to calculate, to make menu plan, diet plan for any of the clients. Okay. In new textbook, it is page number 148. St. George and Mifflin formula is given in page number 148, new textbook. Okay. So it's a variation of the formula that you see here on screen, because on screen weight is in pounds and height is in inches. In textbook, weight is in kilograms, height is in centimeters. So slight variation is there, but both of these formulas are St. George and Mifflin formula, which we will be regularly using to make diet plan or menu plan. Okay, it is considered the most accurate one. Okay. So coming back to physical activity ratio. Okay. You should understand this physical activity ratio, physical active, and also the physical activity level, because tomorrow when you will I'll share you how to do the calculations and all. When we will do the calculations for making a diet plan, okay, you have to come up with the calories, how much calories we can allow this client. Okay, so to come to that final conclusion of calories, you should know what the physical activity level is. Okay, how did it came, what is the use of physical activity level. Okay, so before going to physical activity level, this is the first step, physical activity ratio. Okay, so the formula of physical activity ratio is energy cost of an activity per minute divided by energy cost of BMR per minute. Okay, so let's say you have calculated the BMR. Okay, for example, uh, let's say your height is 160 centimeter. Okay, I will give you the calculation. Height is 160 centimeter. Weight is 55 kg. Age is 25 years. Height is 60 centimeter. Weight is 55 kg. Age is 25 years. And this is a female. Gender is important here for calculating basal metabolic rate. Okay. So those who have the textbook, they can calculate the BMR using the St. George and Mifflin formula. Calculate the BMR. St. George and Mifflin formula is on page number 144 in old textbook, 148 in new textbook. You can calculate this and put the answer in the chat box. What is the answer? Yeah, approximately 1260, 1264, 1265. Okay, will stay near 260. Okay, 1260. So when we talk about energy cost of the BMR per minute, what you have to do? We know the BMR right now. Okay. How many minutes are there in one day? BMR we will use around 1260 to round it up. 1260. How many minutes are there in one day? Not 1 hour. Yes, 1440. 1440 minutes are there. So now you will divide this, you will divide the BMR, okay, BMR by 440, 1440, okay. That is the energy cost of BMR per minute. Okay, your BMR is your whole day's BMR, not for 1 hour. Okay, the 1260 is whole day's BMR. It is not 1 hour's BMR. Okay, so that is how you calculate the bottom energy cost of BMR per minute for any individual. Okay, energy cost of an activity per minute, that you get it from this kind of graph. Okay, so for example, let's say slow walk. The person is using is going for a slow walk. Okay, there is an energy cost that is low. Am I audible? Is my screen visible? Yeah, so doing energy cost of an activity per minute, these all scientists have calculated that if you eat something, okay, for a 1 minute, how much energy you're using it. You're doing your homework, you're washing something, going to school, traveling. Okay, for 1 minute, how much energy is being used. Okay, scientists have already calculated that. You divide that with the energy cost of BMR per minute. Okay, you will get the physical activity ratio. Okay, so that's how they have come up with the physical activity ratio you see on screen. Okay, you are on competition, you're doing some physical education like gymnastic. Okay, PT class is going on, cycling, fast game, fast walk, taking any break. Okay, how much, what is the physical activity ratio? Using this formula they have come up with this graph. Okay, so these graphs are ready made, it is already present. Okay, these graphs from various schools of nutrition, they have calculated it and it is already present. Okay, how much energy you will lose if you walk for 5 minutes or 15 minutes or 10 minutes. If you google it, you will get an answer. Okay, because these physical activity ratios are already done and dusted. Okay, all the activities that a human being can potentially do, any form of activities, okay, from the day to day life, a modern human being, whatever activity he or she does. Okay, the energy cost of it per minute, the physical activity ratio are already pre-calculated. Okay, you don't have to break your brains to find it. But right now, is it clear to you how this formula came into existence? Okay, how do we get this graph? Is it clear to all? So this is physical activity ratio. Okay, the denominator is the BMR per minute. Numerator is whatever activity you are doing per minute. Okay, in both energy is lost. Every minute BMR and basal metabolic rate utilizes your energy. Every activity you do, okay, that is also utilizing energy. So that is numerator and denominator. And that is the physical activity ratio. Okay. Why physical activity ratio is used? That we will see in the next calculation, that is physical activity level. Okay, So let's say if I give you a combination, okay? Let's say I give you a combination of a person who is doing homework. Okay, I will give you 5 activities. Who is doing homework? Okay, who is eating a meal? Okay, playing video games, going to a parlor. Okay, and washing up. Doing homework, eating a meal, playing music, going to a parlor, and washing up. Okay, these 5 activity, is it making a person sedentary, moderately active, or very active? Sedentary, right? Because we do not get to choose, okay, how much like we cannot be judgmental in that, okay, because the graph has shown, these all activities come under low physical activity ratio. When you add up all these and take an average of it, it is still going to be low, and that average is your physical activity level. Okay, so if I give you another example, okay, a person who is traveling by bus, okay, who is walking fast, okay, who is going to school, who is getting physical education done, okay, who is taking a break. Is it moderately active? Moderately active? But it is not sedentary. It is nowhere sedentary. High active. It comes under moderate to high. Okay. It is more than moderate. Because fast walking is there, physical education is also there. Okay. So it is a little bit more than moderate. So these conclusions, break is rest. Taking a break means rest. Okay. So yeah, this is how you come to the conclusion of physical activity level. Okay. And that is the physical activity level. So far we were discussing physical activity ratio. Now it is PAL, physical activity level. Okay. So when you do the average of physical activity ratio, you get an answer, and that determines, are you sedentary, are you low active, very active, okay, or hyperactive. Okay. So when you add up these numbers, okay, parlor is around 1.5, okay, cycling is around 4.2, 4 or something 4, okay, taking part in a competition is 5. Okay, when you add up all these observations, sum of the observation divided by number of observation, how many activities you're looking at, and what is the number of this sum of these activities, when you do that, you will get an average. Okay, if that average is between 1 to 1.39, it means you are in your client is a sedentary person. Okay, if it is between 1.40 to 1.5559, it is low active. Okay, this is the range of physical activity level. Okay, very active, and anyone who is very active can go up to 2.5. Okay, so this is how you take the average of physical activity ratio to find out what is the physical activity level of your client, because this is important to come up with the calories. When you multiply, do you remember just now we have done the calculation of BMR? Just now you have done the calculation of BMR. Do you remember that formula? St. John and Mifflin. And we got an answer of approximately 1260. Somebody got 1264, somebody got 1265. Okay. So remember, when you multiply, you have to multiply the physical activity level to the BMR. Okay. Because why you have to multiply? Basal metabolic rate will not change, but your physical activity is also using energy. Okay. You can't forget the physical activity a person is doing. You have to include that also in the diet plan that you make. Okay, so that's why we require BMR and the physical activity ratio of a person to give them what is their maintenance calorie or whatever the target calorie is. Okay, that comes in the third step. But so far, is it clear to all why we have to take BMR and why we have to consider physical activity level? We cannot forget physical activity level, otherwise the person will lose a lot of muscle mass. Okay, they will become weaker and weaker. So this is the importance of physical activity level for men and women. You will see slight decimal difference. Okay, you don't have to be that judgmental here, because the numerical values you see is very small, very minute decimal difference is only seen in men and women. Okay, you can consider the same for both. No worries in that. It will not drastically change the calories. Okay. So next, coming to thermic effect of food. The thermic effect of food, as I mentioned, protein has the highest thermic effect, which means the rate at which your body metabolizes protein. Okay. The energy your body has to give up just to break down protein, it is the highest. Okay. So when you eat protein rich food, you're definitely going to lose weight because your body will burn more calories just for digestion of the food that you have given. Okay. So thermic effect of food, all the foods that are meat, dairy products, okay, any food that has L-carnitine, beef, any appetite suppressants, caffeine, okay, chromium, lecithin. These all are antioxidant factors. Okay, any food that has all these factors, they have a better thermic effect as compared to other food. Okay. Caffeine also increases your energy utilization. Okay. For BMR, use St. George and Mifflin formula. So resting energy metabolism, as we have discussed earlier, you eat food and you take in oxygen. Okay. Each and every organ in your body produces heat because in each and every organ of your body, energy is produced. As a byproduct of energy, heat, carbon dioxide, oxygen, and nitrogen is released from the cells. Okay, because if you look at this image, each organ system, their cells may be different. Okay, kidneys may have nephrons, brain will have neurons, skeletal muscles will have skeletal cells, adipose tissues will have fatty cells. Okay, blood has red blood cells, white blood cells, heart has cardiac cells. Okay, so every organ is structurally, anatomically, and even at cellular level, they are different. But all the cells, except for RBC, they don't have nucleus, but all the other cells have nucleus. And near the nucleus, you will have mitochondria. Every cell will have mitochondria. And mitochondria is the powerhouse of the cell. Why we call it the powerhouse of the cell? Energy is produced by mitochondria. Okay, you're sitting, you are doing your stuff. Okay, your body is digesting food. Why? Because mitochondria is giving you the energy. Okay, whatever glucose you take, whatever food that you take, it is broken down into small components like glucose, amino acids, lipids, okay, short chain fatty acids and all, and it is used up in the mitochondria. Glucose is used up in the mitochondria to give you energy. Okay, this ATP that you see, adenosine triphosphate, ATP, there are 4 ATPs. Okay, so these are the ATPs are the energy produced. Okay, ATP itself is not energy. Okay, ATP itself is not energy. ATP is a component. Adenosine triphosphate, it's a component. Okay, ATP has to break from adenosine triphosphate, which means adenosine has 3 phosphates. It has to break the bond. It has to release 1 phosphate. Okay, it has to become adenosine diphosphate. Just 2. It has now just 2. After breaking up, it just has two. Adenosine just has two phosphates. So when this breakup happens, energy is released. Okay. But mitochondria does not only release ATP, mitochondria releases other factors as well. So that's your carbon dioxide, the heat generated as a byproduct of energy production. Metabolic water, nitrogen released by breaking down pro amino acids. Okay. So at the cellular level, these many things are produced. One single mitochondria, one single cell is giving you these many attributes. Okay. One single cell in your body is making ATP to give you energy for future. It is releasing carbon dioxide. It is releasing heat. It is releasing metabolic water out of it, out of the cell. It is breaking down proteins, amino acids, and releasing nitrogen. Okay. That will be released out of your body through excreta and even through the urine. Okay. So is it clear how resting metabolism, energy expenditure takes place in the body, even at cellular level? Is it clear to all? Coming to the factors affecting physical activity. Sorry, factors affecting your basal metabolic rate, body composition. So all the tissues and cells in your body should be maintained. Okay. More importantly, your lean muscle. Okay. The areas of your body like muscle, brain, glands, organs, okay, they are more active as compared to other parts of your body. So they consume large amount of oxygen and large amount of energy. So to maintain these structures like muscle, your brain function, glands, okay, you require more energy. So a person who has higher skeletal muscle, higher lean muscle, more amount of lean muscle in their body, they produce more basal metabolic rate. Their metabolic rate is high. More lean muscle that you have, more you will have the metabolic rate, high metabolic rate. Gender, can you guess which gender will have higher metabolism? Yes, males in any gender. Okay, males in any age, sorry, not gender, males in any age group will have higher metabolic rate as compared to women. It's because of hormonal difference and also physiological difference. Next, it's age. With as you age, will your metabolism go down or does it go up? Aging will reduce your metabolism. Okay. Young adults, young children, okay, they have higher metabolic rate as compared to senior citizens. Body size and surface area. Who do you think will have a higher metabolism? A tall person who is lean and tall, or a person who is of a medium height but wide? Yes, a lean and tall person, because their body surface area and body size is more. Okay, when we say body size, it's not weight. Okay, it's not weight. A weight of a person is determined by the fat that he carries inside. Okay, but uh, don't imagine this. Okay, don't imagine this thing. It may sound very absurd. Okay, but you skin a tall person and keep their skin on a side, and if you just skin a healthy person, a chubby fat person, and keep their skin aside, the body surface area that you see is more definitely in the tall person. Okay, the fat person, they will have a limited body surface area, but their entire weight that they carry is inside that body surface area. Okay, so definitely the more body size and more skin surface area you have, more skin surface area, that comes with height. Okay, that comes with height. And even if you're slim, but if you have height, okay, definitely your body metabolism will be higher. Okay, then sleep. If you are well rested, okay, during the sleeping hours also, your metabolism is 10% lower than when you are in awake state. Okay, so if you sleep for a long duration, your metabolism slowly will go down. Okay, sleeping for at least 7 to 8 hours is healthy, but if you're sleeping for 12 to 13 hours a day, okay, slowly your metabolism will go down. Okay, that will affect your metabolism. Okay, you burn more energy when you're awake as compared to your sleep. Then body temperature. What happens to metabolism with body temperature? High body temperature, will it increase the metabolism or reduce the metabolism? For example, when you are suffering from fever, when you have high fever, what happens to your metabolism? Is it, does it go up or does it go down? Yes, with fever, the metabolism goes up. Okay, that's the reason when you are suffering from fever from 2 3 days, you see, you notice a drastic weight loss. Appetite loss is already there. Okay, but you will see a drastic weight loss in your body. It's because your metabolism was very high. Body temperature, increase in body temperature will increase your metabolism also. Okay, also your body temperature is higher in summer seasons. Okay, you lose a lot of weight in summers. It is easier for you to lose weight in summers as compared to winters. Okay, then endocrine glands, hormones, especially thyroxine, thyroid hormone, okay, which has iodine, is very important for metabolism. It stimulates your metabolism. Okay, if you're suffering from hypothyroidism, definitely the metabolism goes down. In pregnancy, different trimester, the metabolism changes. Okay, during the last trimester, that is 8th month, 9th month, 7th, 8th, 9th month. Okay, in these 3 months, the metabolism is high by 12%. Okay, then state of nutrition. Will your metabolism fall down if you're malnourished? Will your metabolism fall down if you're malnourished? Yes, it will. Okay, the state of nutrition matters. Okay, this is the reason why when you do this fat diets, crash diets, okay, for a week or so, you will starve yourself. Okay, you go into a state of malnourishment just to lose weight immediately. But when you start eating properly, you put back a lot of weight than you have what you have lost. Okay, this is the state of nutrition. When you were starving, your metabolism was also going down because you put yourself into a starvation mode. Your metabolism goes down. Okay, because the body wants to survive. If it wastes, it will use up all the energy in doing involuntary things. Okay, there is no energy left for survival, so body knows that it will slow down. Okay, so that maximum energy can be preserved for survival. Okay, so when you go into a state of starvation, of crash diet and all, your body metabolism goes down. So state of nutrition is important to maintain your metabolism. Okay, then environmental temperature, as I mentioned earlier, you will suffer from weight loss issues in winters, but it is easy for you to lose weight in summers. Okay, you sweat a lot, body temperature is high. Okay, then smoking, it's not indicated, but when smokers, chain smokers, when they stop smoking, they tend to gain weight. Chain smokers, when they stop smoking, they tend to gain weight. Then you have your genetics as well. Okay, BMR depends on your genetics. People, a person who is of the two people who are of the same age, sex, height, okay, weight, everything, but their metabolism would be different. Because that is their genetics. Some people are blessed genetically to have a high metabolism. Okay, ethnicity also matters. Metabolism is high in Black Africans as compared to Caucasians or Indian origin people. Psychological states, when you are stressed, when you are suffering from anxiety, when you're having anxiety attack, your metabolism goes up. Okay, to calm down the anxiety, to calm down your stress, the body is working out to calm down. Okay, to make epinephrine, because that epinephrine is the flight and fight hormone. Okay, with depression your metabolism goes down. Okay, with anxiety and stress your metabolism goes up. Then certain pharmacological agents like nicotine and caffeine, they also increase the BMR. Okay. Then diseases like fevers, tumor, cancers, burns, okay, that will also affect your metabolism. So these are the factors that affect the metabolism. Is it clear to all? So that's all for today. Thank you all.